Hello everyone, let us solve this question. Here, equation of a line and a plane are given. P is the plane that contains this line and is perpendicular to this plane. And P1 is the plane which passes through this point and is parallel to the plane P. Then we have to check four options. So, the direction ratios of this line are 2, 3, 1, and the direction ratios of this given plane are 1, 2, 3. Direction ratios of this line 2, 3, 1 and direction ratios of the normal to this plane are 1, 2, 3. P is the plane that contains this line and is perpendicular to this plane. Since P contains this line, the normal to P and this line are perpendicular. So, the direction ratios of this plane, the normal to this plane, is perpendicular to this line. Since this plane is also perpendicular to this plane, so their normals are also perpendicular. So the direction ratios of this plane is perpendicular to the direction ratios of this plane. So by taking the cross product of both of these, we can find the direction ratios of plane P. 2, 3, 1 and 1, 2, 3. So the direction ratios of the plane P are 7, minus 5, 1. So the general equation of such a plane would be 7x minus 5y plus z equals d. Since this plane P, contains this line, so it also contains the point 1, 3, minus 2. Since this line passes through the point 1, 3, minus 2 and this line lies in this plane, so this plane also passes through the point 1, 3, minus 2. So let us satisfy this point in this plane. 7 minus 15 minus 2 is d. So d is minus 10. So the equation of plane P is 7x minus 5y plus z is minus 10. This is the equation of plane P. Now P1 is the plane that is parallel to plane P and passes through the point 4, 2, 2. A plane parallel to plane P will have the normal same as the normal of plane P. So the direction ratios of the normals will be the same. So this would also be the general equation of plane P1. By satisfying this point here, we can find the exact equation of plane P1. 7 into 4 minus 5 into 2 plus 2 is d. 28 minus 10 plus 2 is d. So d is 20. So the equation of plane P1 is 7x minus 5y plus z is 20. These are the equations of these planes. Now let us check the options. Option A is the equation of plane P is 7x minus 5y plus z is minus 10. 7x minus 5y plus z is minus 10. So yes, option A is correct. Option B is the distance between the planes P and P1 is 30. So we know that distance between two parallel planes, let's say equation of one plane is ax plus by plus cz is d1 and equation of the other plane is ax plus by plus cz is d2. Then the distance between them is given by magnitude of t1 minus d2 over under root a square plus b square plus c square. So let us apply this formula in this case, P and P1. These are parallel planes. Distance would be minus 10, minus 20, minus 30 over under root 7 square 49 plus 5 square 25 plus 1. So root 75. This would be the distance between the planes. 30 by root 75 units. But in this it is given that the distance between planes P and P1 is 30. So this option is incorrect. Option C is the distance of plane P from the origin is 2 root 3. So to do that, we can plane P. So we can satisfy the origin here and then use similar formula. So this distance would be magnitude of 0 minus 0 plus 0 plus 10 over under root 75. This will be 10 upon 75 is 5 root 3. So 2 by root 3 units or 2 root 3 by 3 units. But in the option C it is given that the distance is 2 root 3. So this option is also incorrect. Let us check option 4 now. Option D is the acute angle between the plane P and the plane 2x plus 2y plus z equal to 3 is cos inverse 1 by 3 root 3. So one plane is plane P and other plane is 2x plus 2y plus z is 3. The acute angle between these planes. So the angle between two planes is the same as the angle between the normals. So the dr of this plane, the direction ratios of this plane is 7, minus 5, 1, and direction ratios of normal of this plane are 2, 2, 1. So basically this is one vector and this is another vector. We know that A dot B is magnitude of A, magnitude of B, cos theta. So this cos theta would be A dot B over magnitude of A, magnitude of B. So this will be the angle. These are two vectors, the direction ratios of two lines. These are two vectors, and by using this formula we can find the acute angle between them. Cos theta equals A dot B, 7 minus 5, 1 dot 2, 2, 1 over magnitude of this root 75, magnitude of this 4, 4, 1, so root 9, that is 3. This would be 7 2s are 14 minus 10 plus 1 over 5 root 3 into 3. So 4, 5, 5 by 5 root 3 into 3, that is 1 by 3 root 3. Cos theta is 1 by 3 root 3. So theta is cos inverse 1 by 3 root 3. This is the acute angle between these planes. And option D is just this. So yes, option D is correct. So the correct answers are A and D only.